The notes for Unit 5, Lesson 3 will cover the molar volume and the mole. So in this lesson, you will convert between moles and liters by using the molar volume conversion factor. So Avogadro's hypothesis states that equal volumes of gas at the same temperature and pressure will contain equal number of particles. So because we have an equal number of particles, we know that 1 mole is equal to 6.02 times 10 to the 23rd particles. So if we have that number of particles, we know that the gases are also going to occupy equal volumes, which is where this molar volume number comes from. In order for Avogadro's hypothesis to be true, the gas has to be under standard conditions, which is called STP. So STP stands for standard temperature and pressure. And you won't really need to do anything with the values for STP for this unit, but you will see them again next unit. So standard temperature is 0 degrees Celsius. Standard pressure could be written in one of 3 ways. So it could either be 101.3 kPa, which represents kilopascals, or it could be 1 atm, which is atmospheres, or 760 millimeters of mercury. So these are the units that standard pressure is in. So the molar volume is the fact that 1 mole of gas will occupy 22.4 liters of space. So this is your new conversion factor. 1 mole is equal to 22.4 liters. So liters, again, represents volume. Yikes, my pen isn't working very well. All right, so now on your mole map, we have covered all calculations for the left side. So here is volume. So if you wanted to write in that this is liters, sometimes that is helpful. So you can convert between moles and liters. You can convert between grams, which is mass, and moles. And then you can also convert between moles and molecules. So now we are moving around all on the left side of the mole map. So the process for these problems is the same. It's just now using a different conversion factor. So if we want to know what's the volume, again, volume is expressed in liters. Does 3.7 moles of N2 gas occupy? So we start with the number given in the problem, and we set up our chart. Whatever unit you start the problem with gets transferred down to the bottom of the next step. And then we're going to go over to our mole map. We're going from moles to volume. So I know that I'm converting from moles to volume. So this is the conversion factor, that I'm going to use. So if moles goes on the bottom, the number 1 goes with the unit mole. Whatever 1 mole is equal to is going to go on top. So then moles cancels out with moles. You multiply the numbers across the top, divide by the numbers along the bottom, and then you have to round to sig figs. So 3.70 has 3 sig figs, 22.4 has 3 sig figs, so we would end up with 82.9 liters. So 3.70 moles of gas under standard conditions would take up 82.9 liters of space. All right, the next question is asking how many moles. And then we are given 67.2 liters. So I'm going to start with the number given in the problem. Make sure you label everything. Set up your chart. Whatever unit you start with gets transferred to the bottom of the next step. And then you go back to your mole map. I'm going to erase my markings here. So we are converting between moles and liters again. So the unit liters goes with the number 22.4. So that has to go on the bottom. Whatever that number is equal to goes on top. Liters cancels out with liters. And again, you multiply the numbers across the top, divide by the numbers along the bottom. So for this calculation, we actually get an answer of 3. However, we have to round to sig figs based on the numbers that went into the problem. So 67.2 has 3 sig figs, 22.4 has 3 sig figs. So we would have to convert our answer into 3 sig figs. So it would end up being 3.00 moles. So when you're reading your mole map, as you're finding your starting and ending point from the problem, if you are going from particles to liters, that would be a 2-step problem. If you're going from moles to grams, that would just be a 1-step problem. So if you use your mole map, it actually tells you, how many steps the problem will have. If you're going from volume to grams, that will be a 2-step problem. So let me know what questions you have regarding the mole map in this process. You guys are doing a great job.